So here this question is given. In this question it is given that the nameplate rating secondary side V2 dash, it is given as 2400 angle 0, right? And secondary side load current referred to primary side, it is also given, that means I2 dash is also given, right? So that is 62.5 angle minus 36.86, because power factor is given 0.8 lagging, so minus for lagging 36.86, right? And it is also given that equivalent, Z equivalent, right? What is Z equivalent? Z equivalent is this R1 equivalent plus X1 equivalent. R1 equivalent is R1 plus R2 dash, and X1 equivalent is X1 plus X2 dash, right? This is V2 dash, this is I1, this is V1, this is ICRC, this is IMXM, this is I0, right? So this is the circuit, which is the equivalent circuit, approximate equivalent circuit of the transformer, in which the secondary side is referred to the primary side, that's why R2 dash and X2 dash and V2 dash, right? And shunt branch is shifted further towards supply terminals, towards V1 and I1, right? Now here you have to calculate, apart from this it is also given that the magnetizing current IM, it is given 1.583 angle minus 89.3, and core loss current IC is also given 0.2454.7 ampere, right? These two values are given. Okay, so now you have to calculate input voltage, you have to calculate input current, you have to calculate input power factor of the transformer operating at rated load with 0.8 power factor lagging, right? So how to solve this question? Just apply Kirchhoff's voltage law in this loop, the outer loop, right? When you apply Kirchhoff's voltage law, you will get V1 is equal to V2 dash plus I2 dash into Z equivalent. V1 is equal to V2 dash plus I2 dash into Z equivalent, right? So put the value of V2 dash, which is given 2400 angle 0, I2 dash is given 62.5 angle minus 36.86, Z equivalent is given 0.985 angle 66.04. This is given. Put all these values, get your V1, that is 2454.94 angle 0.7, right? Now IC and IM are also given, so from this IC and IM take phasor sum of IC and IM will give you I0. I0 is phasor sum of IC and IM, so it is 1.6018 minus angle minus 80.49, right? So now you just have to calculate I1. I1 is basically I0 plus I2 dash. I1 is equal to I0 plus I2 dash, right? This is dash, I2 dash. So it is 63.67, so angle minus 37.86 ampere. So now this is the input current I1, right? This is the input voltage V1, right? So this is first answer, that's your second answer. And now power factor, how to calculate? Input power factor you can calculate, that is angle between V1 and I1. Angle of V1 is 0.7 degree, angle of I1 is minus 37.86. So what is the input power factor? Input power factor is cos 0.7 minus of minus 37.86. So 0.7 is the angle of voltage, minus 37.86 it is angle of current, this is angle of V1, this is angle of I1. So cos angle between V1 and I1 will give you the input power factor angle. So cosine of that angle will give you the input power factor. So minus of minus become plus, so it will become cos of 38.56, cos of 38.56, so that is equal to 0.781 lagging, right? 0.781 lagging, right? So you see now this is less than 0.8 power factor, that is load side power factor. 0.8 power factor is load side power factor, but input power factor is less than 0.8, right? So that is the answer, 0.781, right? Because primary winding is also consisting of windings, copper winding and winding is inductor, so that will further consume some reactive power. So that's why power factor will further deteriorate, right, from 0.8 to 0.781. 0.781 lagging is the input power factor angle. Thank you very much. Thanks for watching.